Alright, hi guys. Today we are talking about Chapter 1, Lesson 2, The Nature of Science. Our focus question, what are the characteristics of scientific inquiry? Hopefully by the end of this lecture you can answer that question. Here are your vocabulary terms. If you have not taken the time to complete your vocabulary activity, please pause the video and go complete that, then come back. These terms are going to be used throughout the presentation, and it's important that you understand them before we get started. A review vocabulary term, investigation, a careful search or examination to uncover facts. Now, these investigations can be scientific or non-scientific. Okay, think about all the crime shows on TV. Okay, they are constantly investigating to uncover facts. A scientific investigation is trying to determine facts about the natural world around us. What is science? Well, science is the use of evidence to construct testable explanations and predictions of natural phenomena, as well as the knowledge generated through this process. Two key things. All right, it uses evidence. Okay, if you don't have evidence, it's not true science, and it must be testable. Okay, to do true science, to do a true investigation, you must be using evidence that is testable. Okay, the nature or essential characteristic of science is scientific inquiry. Scientific inquiry is both a creative process and a process rooted in unbiased observations and experimentation. You might be wondering, well, science isn't really that much of a creative process. Well, it is. Whenever you're designing an experiment, you have to think about it in a lot of different ways and come up with the best possible way to gather your evidence. It also must be unbiased. Okay, you can't go looking for one explanation that is going to support what you already think. You have to go in with your eyes wide open, and you must be willing to accept whatever outcome you come up with, whatever outcome the data, whatever outcome the evidence shows. A testable explanation of a situation or a phenomenon is called a hypothesis. A lot of times people say that it's an if-then statement. So a hypothesis might be, if I water my plant with salt water, then it will die. That is something that I can test, something that I can gather data on, and something that I can make observations. Now, a hypothesis is different from a theory. Okay, a scientific theory is an explanation of a natural phenomenon supported by many observations and experiments over time. Okay, it's not just something that some guy on TV says, I've got a theory about that. Well, they might have an idea. They might have some data to back it up, but a true scientific theory is supported by many, many, many observations and many, many experiments over time. Now, a theory is different than a law. A scientific law describes relationships under certain conditions in nature, but it doesn't explain why that relationship exists. Okay? Theories do not become laws, and laws do not become theories. They are not interchangeable. Science makes observations and draws conclusions. Scientists choose subjects to study and decide what types of data to collect. They choose what kinds of data to collect based upon what their hypothesis is, what they're trying to collect information about. They use different tools to collect data. Throughout the year, we will be collecting data using different methods, using different tools. Once the data is collected, scientists will analyze it and draw conclusions. The process of combining what you know with what you have learned to draw logical conclusions is called inferring. The conclusions themselves are called inferences. All right, we create inferences every day. Okay, we take what we already know and what we are currently learning, and we put it together and make inferences. Science expands knowledge. Scientific explanations combine what is already known with evidence from additional observations and experiments. Science is driven by the search for new knowledge, and it constantly reevaluates what is already known. Back in the 1500s, people believed that the earth was flat, okay? But scientists were driven by the search for new knowledge. They gathered new evidence and they reevaluated what was known. Okay, now we know that Earth is a sphere because scientists were looking at new data and reevaluating what was already known during the time. Pseudoscience imitates science. The prefix pseudo means fake or false. Okay, so pseudoscience is false science. All right, it's not driven by a search for new knowledge. Okay, it's driven by cultural or commercial goals. They're trying to make money. Okay, and new questions and additional research are not welcomed. Okay, they already have their product. They're not worried about improving it because they know it's not going to work. They just want to sell as much of it as they can. Okay, they're not concerned with generating new knowledge or making the world a better place. Science challenges accepted theories. Scientists actually welcome debate about their ideas. Okay, they're not going to get offended if you ask questions and want to know more. They actually encourage that. Okay, they look for people to challenge them, to say, hold up, I don't understand how you got how you came to this conclusion. All right, science advances by accommodating new information as it is discovered. Okay, science doesn't sweep it under the rug. When new evidence comes to light, they try to make what is already known fit that. And if it doesn't, then more research is conducted. Science questions results. In science, data that are not consistent with current scientific understanding are of interest and lead to new investigations. For example, understandings about relationships between organisms change as new information becomes available. In pseudoscience, these inconsistencies are ignored. They're just kind of swept under the rug and brushed aside, and they hope that you don't bring it up again. Now, a relationship between organisms that was rethought in, I say recent history, within the past couple hundred years, was the relationship between birds, bats, and humans. For the longest time, it was believed that birds and bats were very closely related because they both flew. They both had wings. All right, they looked sort of similar. So it was just like, oh yeah, those two things that fly in the air, they must be closely related. All right, but scientists began looking at the bone structures of those organisms, and they compared the structure in the bat and the human and found that it was more closely related. They had more similar bones than the bat and the bird. So scientists started digging into that more and more and discovered that bats and humans are more closely related than birds and bats. All right, and we're going to talk more about that later this year. Okay, I don't want you to get stressed out or worried about that right now. Okay, right now this is just an example. Science also tests claims. Scientists use standard experimental procedures. There are certain ways that things are done that help ensure that mistakes are not made. Their claims are based on large amounts of data and observations obtained from unbiased investigations and carefully controlled experiments. The unbiased and carefully controlled parts are very important. All right, they're not going into this experiment looking for a certain outcome. They're going in with their eyes wide open, willing to accept whatever outcome may happen. They are also carefully controlled experiments, meaning the thing that they are changing is the thing that's causing the outcome. Okay? It's carefully controlled. They're making sure that it is clean, that there's no interference from outside sources, that their data, their outcomes are actually due to the changes that they made. Pseudoscientists make claims that cannot be tested or that are a mixture of fact and opinion. And a lot of times you can't tell where the fact ends and the opinion begins. Science also undergoes peer review. Before it is made public, science-based information is reviewed by a scientist's peers. They will run the exact same experiment, use the exact same steps to verify that the results that the first scientist got were actually good and true. Peer review is a process by which the procedures used during an experiment and the experiment's results are evaluated by other scientists who are in the same field or who are conducting similar research. It's just a way to double check that the science is good, that the procedure is actually what worked, that the data is actually true. Science is not limited to the laboratory. Science fills our everyday lives, okay? It has brought advances in medicine, transportation, communication, agriculture, and overall quality of life, okay? Think about it. When you get a headache, you take Tylenol. That's brought to you by science. Transportation, you got to school or you got to wherever you are using some kind of transportation, probably a car or something with an engine. Communication, how many of us have a cell phone? That is because of science. Agriculture, the food that we eat, okay? It's engineered by scientists, and there are pesticides and herbicides that are used on it to ensure that it is good quality food, that it's not eaten by bugs or, some kind of bad thing growing, okay? And our overall quality of life has been improved by these things. Okay, water quality. The water that I get out of my sink in my kitchen is safe to drink because science tests it. Okay, there are guidelines, there are things that keep my water clean thanks to science. Science literacy. A scientific literate individual is an educated consumer who can participate in discussions about important issues. A scientifically literate person can look at a claim and figure out whether it is true science or pseudoscience. They can look at it and say, this thing doesn't make sense to me. Your claim, this is an opinion rather than a fact. Okay? They can spot that in pop culture, in the world around us, and be able to avoid those situations. Ethics is a set of moral principles or values. It's important for scientists to have ethics so that they know where the boundaries are, what they can and cannot do. How can you be scientifically literate? Well, it's important to develop critical thinking skills. Scientists analyze, evaluate, and critique scientific explanations. Each scientific explanation must be closely examined, and the explanations are often debated. To make informed decisions about scientific topics, you must also be able to analyze, evaluate, and critique scientific explanations. So you have to understand what the process is, look at it from an outsider's perspective, and figure out if you think that the outcomes are actually true, if those outcomes are actually possible. You must also examine the evidence. It can be gathered in a variety of ways. It can be empirical, verifying explanations by using experience or investigations. Logical, evaluating an explanation using reasoning. Experimental, by gathering data based upon controlled investigations. Or observational, gathering data based on observations. Those are how we gather evidence, okay? These look like big, scary words, but we do them every day. We're going to talk about ways that we gather evidence in class. We don't have time to go into a lot of detail right now. You also, to be scientifically literate, must evaluate promotional materials. Some promotional materials make scientific claims. You have to be able to analyze and evaluate and critique those claims to see if they are actually based on true science. Okay, you have to think about the motives behind them and the evidence on which the claims are based.